to the abyss. Hey, Owen, I hope you're listening. Why didn't you guys say hi to Owen? Loud. Yeah, see, they miss you, Owen. Is Owen the only one missing? Yes? Yeah. We have full attendance besides Owen. Owen, I hope you're enjoying vacation. I think he's in Florida, isn't he? South Carolina, Florida, kind of the same place. Well, okay, we went to South Carolina. We went to Savannah, Georgia last year, which is close to South Carolina. It looked all like Florida. It was warm, had sand and water. So, anyway, I suppose he's getting wet. Alrighty, let's go over here. And so we're going to have some music, a little intro music here soon. And so this is just to wake you up, but you guys are pretty good. Here we go. For the people out there, it's just cheer dancing. Okay. That's the best dancing I can do. I don't drop anybody. Alrighty. I've told you that story, right? About the time I took ballroom dancing. Did I tell my ballroom dancing story? No. Okay. So hardest class I ever took in college. Since it's college day, hence the Bemidji State. So I went to Bemidji State because it was 320 miles away from home. It met my criteria. Okay, I wanted to be as far away from home as possible and cheap as possible. And I didn't have to take a test because, they just wanted money. And so I paid my $15. And I was a human being and my heart was beating. So they took me. Okay? And so it's gorgeous. It's gorgeous up there. I walked through the woods every day to class. And then I remember the yellow leaves falling down on my head, and it was like 68 degrees. I go, I'm on my way to math class, and I'm walking through the woods. There's nothing better than this. Well, you've been there, right, Aiden? It's gorgeous. And you're right on the lake. And so the football field is right on the lake. And so I wore my Bemidji State stuff because it's College in the Schools month. And so the stands are packed with excited students for this football game. And there are these group of people called cheerleaders. They would stand in front of the fans and they would do cheers that you would follow along. We used to have them here a long time ago. Okay. And so they get up there. Okay, here's the cheer I learned. You ready? Okay, this is my favorite cheer. Now think, if you're the opponent, how this strikes fear into your hearts. Okay? I'm a beaver, you're a beaver, we're a beaver all. When we get together, we do the beaver call. Okay. Landry, pure fright. Think of what, if fans aren't afraid to do that in front of other people, they're not afraid to do anything, right? So that was my experience at Bemidji. So anyway, the love of my life is going to Bemidji, Denise, okay? So when you have a relationship with a person, you go through stages of love, okay? That's just the way it is. And for guys, even though they don't tell you, it's unbelievable, okay? And you're at a point where all rational decision is out the door because you want to be with this person all the time. And females are a lot smarter than guys. They are the superior gender. I've already understood that and have allowed myself that. And my future wife said, let's take a class together. She's going to be an elementary teacher. I'm going to be a math teacher. We don't take same classes. She doesn't take abstract algebra. I don't take kitty lit. And so because Bemidji required 5 Phi Ed classes and ballroom dancing fell into as a Phi Ed, she convinced me to take ballroom dancing. Now, you also have to understand, disco was at its rage at that time. So it's a huge class. And Dr. So-and-so, she was an instructor they got from New York, some hoity-toity college in New York, to teach this class. And she had a male grad assistant to help her. And there are 3 tests, Jack. The first test was someone you want to dance with. Well, that was pretty easy. My future wife, Julie. The second, well, I'll talk about the second one. So I have issues. You know how you have strengths and weaknesses, everybody has? My weakness is, 1, I can't keep a beat. If you watch, I'll either refuse to clap my hands at a pep fest or I have to stand by somebody who I can watch when my hands are supposed to hit together. The other thing, if there's more than 1 step in a dance, I can't do it. So my favorite dance is simply from moving side to side, left, right, left, right, left, right. It's easy. There's no movement besides left, right, left, right, left, right. I'm really good at that. Okay, and I also can do the twist by Chubby Checker. Those are the only 2 dances I can do. Well, we practice in our residential hall rooms. And she says, you can't keep a beat. No, I can't. You can't remember past 1 step. No, I can't. She said, what I'm going to do is I'm going to say 1 and 2 and left foot, right foot. I'm going to whisper it in your ear. And you just follow along. And I'm going to lead. But act like you're leading. So we faked it. And I took this class, pass, no pass, which is always an option to you. You don't have to take, for your non-major classes, you don't have to take all of them for grades. You can select certain ones to be pass, no pass, which means you get credit, but it doesn't wreck or help your GPA. Does that make sense? So you can remember that. It's an important bit of information. So I had taken this pass, no pass, because I knew, Denise, of my difficulty. Okay. The second day, so we passed the first test. We did the waltz. And the waltz of ballroom dancing is the easiest. It has 2 steps. And I luckily remembered the 2 with the help of my wife. The next one was the cha-cha-cha. It's a Latin dance. Luckily, the random person that got selected was my wife's sister, who knew also of my handicap. She did the same thing. The third test was with the instructor. I got the tango. And if you've watched with Dancing with the Stars, they do the tango. And we had to dress for the part. So I had a polyester shirt that looked kind of silky and blousy. You know what I mean? And I'm nervous. I mean, I'm sweating. And my wife said when the instructor pressed her hand to the middle of my back and pulled away, you could see her handprint on my back. There was so much sweat. Well, at the end, you do a dip. And she's got a rose in her mouth. And I do this dip. Well, I'm sweaty. My hands are sweaty. I drop her. All I care is I got my P from Bemidji State in ballroom dancing. That's my story. Okay? And now it's on the abyss. I've confessed. Okay. All right, we were doing these problems. Am I right? Okay. And had we started number 7? We finished number 7. That was the problem from HE double toothpicks, if I recall. Correct? Right? And at the same time, we've learned kind of a shortcut. Okay, have we started this one? And this one's kind of goofy because I forgot the F. So, the shortcut for figuring out the derivative. And are we okay that x prime means derivative? Okay. Anybody confident to know what this is? Or are you not 100%? Ryan's confident, okay? Did you do something first in your head before you knew what the derivative was? Can you explain to me what you did in your head?
I switched the 1 over x squared to negative, or x to negative 2.
Right, so you wrote this function as a power function. Everybody okay with this? So if it's a fraction, you're going to bring it like this. If it has a radical, everybody understand what I mean by radical? You're going to get it like this, all right? Okay, so then you want to explain to me what your process is next, Ryan.
So you take negative 2 and you multiply by the leading coefficient.
Which in this case is 1?
Yeah.
Okay.
That equals negative 2.
Okay.
And then you subtract 1 from the power.
And you get,
Negative 3.
okay, so somebody, I think it was Sophia, asked, would we get credit for this on the quiz if we just stop here? And the answer is yes, you would get full credit. Everybody okay with that? And that is showing your work right here. So I'm going to tell you right now that on the quiz on Friday, if it does not ask you to do the limit definition, and it simply asks you to find the derivative, that's all you have to do. Does everybody understand that? If you do the limited definition, you can get the same answer. I hope you would get the same answer. Okay? But it's going to take you a lot longer. Does everybody understand that? Okay? So, since one of the questions will be, how do you do it using the limit definition? I'm going to show you that. Now, on number 7, did I use h or did I use delta x? H. I'm going to use delta x here. So I'm going to start with this. The limit as delta x goes to 0. I'm going to get so you can see it. And I'm going to have 1 over x plus delta x squared. So what I do is I input that into the function, don't I? Minus, I always have a minus of f of x, of the function that I give you, all divided by delta x. Are we okay with that? If you look, it's on the window right here. Tomorrow, right next to Denise, on the right-hand side, there's going to be more stuff. It's going to be what we're going to talk about today. Okay? It will be the shortcuts, and one of the shortcuts that Ryan just told us about right now. Okay? All right. So now, Julia, do you have any idea what I should do from here? You are right, to get a common denominator, and that's what I'm going to do. And would you agree that the common denominator is the product of these two denominators? Okay. So are you okay that I'm going to multiply this by x squared on top and this by x squared on the bottom? So I'm going to do this. I'm going to write 1 over delta x over here, which is this thing. I'm going to multiply by its reciprocal. And down here, I'm going to have x squared times x plus delta x squared. Are you okay with that? And up top here, I'm going to multiply this by x squared, so I'm going to get x squared minus parentheses x plus delta x, that quantity squared. Julia, does that meet your approval? And is that what you would have done? Perfect. Okay? Landry, I'm going to expand that. Do you know what I mean by expanding that? In my head, I'm going to take x plus delta x times x plus delta x. I'm going to get 3 terms, which are all positive, and since I'm subtracting, I'm going to make them all negative. You would agree with that? Okay. Caitlin, you would agree with that? Because I'm trying to do some shortcuts here. Okay. And so I get the limit as delta x goes to 0. I get x squared minus 2x delta x minus delta x squared all over x squared times x plus delta x squared, and over here times 1 over delta x. Does that look correct, Landry? Okay. Tie. A little bit of death going on, would you agree? Yep. Right here. It's gone. Julia, probably a little bit too aggressive, but that's just how I feel today, okay? So, Jack, can I factor out a delta x?
Yes.
So I'm going to have equals the limit as delta x approaches 0. And I'm going to have a delta x here. I'm going to have a minus 2x minus delta x over. Here's 1 over delta x, because I forgot that second period. And down here I have x squared times x plus delta x squared. Now if you notice, Jack, I never multiply out the denominator. I don't find it helpful at all. And I find it messy, and then it gets confusing. So I keep, if the denominator is factored, I leave it factored. All right? So I have some more simplification that's going on, and it's right here. Okay? So Elijah, the thing that caused the problems, delta x in the bottom, is gone, isn't it? Right? So now I can substitute 0 into delta x. What will I get on top, Elijah? A negative 2x. All right, so this is going to be 0, correct, Elijah? What's x plus 0? And then I'm going to square that x. So what am I going to get? And then I'm going to take x squared times x squared, and what am I going to get? No. X to the 4th. Does everybody agree with that? Because you get x times x, which is x squared, times another x times x, which is a total of x to the 4th. How many x's am I multiplying? Okay. So, Justin, look at what Ryan said we're going to have. Look what we came up with. Was Ryan a liar? Why not? I should not said. I should have said calculated incorrectly. There. Sorry about that.
Take out 1x.
Right. This is x to the 1st, right? It can simplify and becomes this, which is the same thing, correct? Slick. Isn't this a lot nicer than this? Alrighty. Next page. So what you're going to be asked to do in the homework is take each one and write it as a power rule. So this is the ones that are on the front. Remember we had f of x equals 7, right? Right? That was our first one. I can really think of that as x to the 0 power. Because tie anything to the 0 power is 1, correct? And now we can use that rule. We're going to take 0 times 7. And that's going to give us what? 0. And I know that's going to be x to the negative 1, but you know when you have a fight between 0 times anything else, you know who wins? 0, every single time. It's like the ultimate superhero, supervillain. You just have to decide, right? So you're going to get the derivative is equal to 0. And I can't even write it in power form. The next one, I think, was x. And I can write this in power form. And notice I am showing its coefficient. It's up to you whether you want to show 1 or not. Does everybody understand that? And then when I take the derivative of this, I'm going to get 1 times 1, which is 1, times x to the 0, which is 1. Everybody okay on that? I suppose I should write x to the negative 1 equals 0. So I'm just verifying the answers we got, right? The next one, I got 1x squared, and so I'm going to have 1 times 2, which is 2, x to the first, or simply 2x. The next one was 1x cubed, which gives me x, which gives me 3x squared. The next one I'm going to write as f of x, 1x to the negative 1, which is going to be negative x to the negative 2. Are you okay that I don't write this negative 1? Which you can leave as your answer on a quiz. But you got to be okay where this came from. Because this derivative is going to show us something when the denominator is 0. It's going to show us something when the denominator is 0. And it's not going to make sense. It's going to be, we're going to end up finding what we call global extrema. So the high and low points of a graph. And when it's in the denominator, it says something special about those, okay? I don't want you to worry about it, but you got to be okay with that. You should be okay with that, shouldn't you? All right. So the next one is, I'm going to write it again. This one will be 1 half x to the 1x to the 1/2 power. So its derivative is 1 half x to the negative 1/2, which is the same as this. Or you can even get by with this. And again, any of these three right now, you can have on your quiz, right? If you just choose that, you're going to get full credit. That's going to be your work. Number 7 was this. And I think we have this. Which is equal to this. And if you want the radical, I suppose you could. Is everybody okay that radicals are fractions? Fractional exponents, I mean. Okay? All right. And you understand what's the denominator and what's the numerator. All right. And number 8. All right? So far, that's the hard part. This example, the constant rule. And like I said, these rules are going to be right across from Denise tomorrow. You're going to see derivatives. That's what the caption is going to be. And I'm going to have the constant rule. And it says, if f of x is equal to some constant, its derivative is 0. So if I have f of x is equal to 3, its derivative is equal to 0. If f of x is equal to 7, its derivative is equal to 0. That's showing your work. Holy buckets, they're loud. I can hear them. Are we all right on that? Now, Alexis, you ready? Here's my question. Let's say we're going backwards, and I know the derivative is 0. Can you tell me what constant the function was? It could be any number, right? We'd have a problem, wouldn't we? We wouldn't know what number that is because the derivative of all constants are 0, correct? But if I told you here that the derivative was 1, where did it come from? What did we take the derivative of to get a derivative of 1? What would it have to be? It'd have to be x. If I got 2x as my derivative, it had to come from x squared, didn't it? But that's not the same as with a constant. Don't worry about that. That's down the road. Do you know what we call, you know how you learn to add? And then we learned this new operation called subtraction, which is doing the opposite. And then you learned how to multiply, Caitlin. And then you learned how to do the opposite, and we called it divide. Where you're learning how to take the derivative, we have an opposite. Guess what it's called? This is my favorite part of this class. It's called the antiderivative. 666. 2 times 333. 333 is 666. Have you ever thought about that? Notice we're getting close to Halloween. Just saying. Kind of spooky. Alrighty. It is Aiden's turn. F of x equals x. Oh, sorry, we got the power rule. The power rule is this. If n is some rational number and f of x is x to the nth power, notice the coefficient is 1. Its derivative would be n times 1, or n, and then you would subtract 1 from n, correct? Ty, I don't like that rule. Because very rarely is it 1. It's usually some other number, right? So I write, this is what you'll see by Denise. Here's my other coefficient. I say the power rule is this. It's going to be a times that n times x to the n minus 1. That's what you guys have been doing already, right? That's the power rule. So we'll have the constant rule up there, we'll have the power rule up there. They'll be right to the left of Denise. So, back to Aiden. Aiden, f of x equals x. What is its derivative? 1. Alexis, f of x equals x to the 4th. Find dy dx. Now, here, see, I'm trying to throw you a curveball. But you're smarter than the curveball. Because you know f prime of x, another name for it, this is a Chevy, this is a Ford. They're both cars. Right? The Chevy may not like the Ford. I don't care. They both have the same purpose. To get somebody from one place to another, correct? So this has the same purpose. It's finding the derivative or the what?
Instantaneous rate.
The instantaneous rate, correct? Or what else?
Slope of the tangent line.
Perfect. So what is the formula that would give us the instantaneous rate or slope of a tangent line? Can you tell me?
Wouldn't it be the an x to the n minus 1?
Yeah, but you're going to use the power rule for this one. F of fx equals x to the 4th. So it'd be what?
What does it?
Take the derivative of this.
The 4x to the 3rd power.
Third power. That will compute the instantaneous rate if I knew x, right? If I knew what the x coordinate is, I could figure out the slope, correct? I could figure out how fast I'm going, what the rate is, correct? Next page. Denise, I can't see your eyes because of your hair. Your hair is getting long. You know that? Have you ever thought of shaving your head?
No.
Okay. All right, so let's take a look at this. Ooh, it's not even, this looks weird. It looks like it needs to be focused, doesn't it?
Yep.
How do you get this thing autofocus, auto-tune? It doesn't look like it's focusing. Focus. Maybe I need to push that. Ah, if you push the button that says focus, it works. Just like if you push the button that says power, it turns on. All right, what are you going to do here? Notice it says find the slope of the tangent line when x equals 2, when x equals a negative 1, when x equals 4. You know why I'm asking this question on your notes? Do you have any idea why I'm asking you to do this one? If you don't know, you can say, no, I have no idea why you're asking me. Because this is a question that's on the homework. Okay? So what are you going to do here? I'm going to make it a little bit bigger. Not yet, because when I plug these numbers into here, I don't get the derivative. I don't get the slope of the tangent line. You know what I get when I plug 2 into here? And I get the 5th root of 8? You know how I got 8? I put 2 in there, I cubed it, got 8, and that's the 5th root of 8, which I don't know what that number is. Okay. Our machine knows that, right? Okay. You know what that gives you? That doesn't give you the slope of the tangent line. It gives me the what? What's the purpose of f? To give you y. And y is not the slope of the tangent line. It's a certain spot on the graph, right? So I have to figure out what the derivative formula is first. Is this in power form? Is it x to some power? I don't think so. Well, x to the third, but then you got this doohickey that's wrapped around it, right? I mean, it's like a gift. It's got a little ribbon wrapped around it, right? So what I'm looking for to get you to do is say x is to what power? And because you see this crooked thing right here, oh, I know what I found. Does anybody know what this thing is called? It's called a radical, correct? That 5 in there is called an index. It sits by the crook. Do you know what I mean by a crook of a tree? Have you ever heard that, Denise? So if you have a tree, it has branches. And we had a living room that had a tree that looked like that, had branches. And I loved to climb trees. So our living room looked out of this tree. And I was 7. And when you're with a whole bunch of adults, when you're 7, you're bored. So I went outside. It was Thanksgiving. It was a beautiful Thanksgiving day. So I climbed that tree. And then I got stuck. And I'm hanging like this in the crook of the tree. And I'm yelling, help. And I'm crying because I can't get up. And I'm hanging like this and I'm dangling there. And it's a big picture window. And I can see through it. And who do I see? Adults. And I'm yelling. And what are they doing? Laughing and drinking beer. And I know my dad, with his Greenbelt Premium, looked out at the window and then turned away. I know that had to happen. So I move my head like this, and my ears are getting folded back, and it's in pain. And then I fall to the ground, about 7 feet. And I come bursting in. And I said, I was hanging from a tree for 20 minutes and no one loves me and I fell to the ground. You know what they did? They all laughed. Hence, that's where my other story came from today. From the crook of this radical. Right there. So, I've been stalling, Denise. What's the exponent here? 3 what? Over what?
5.
Over 5. It's a fraction. Okay? So now you're going to take it the derivative. There's a coefficient of 1. What's out front? 3 over 5. X to what power? A negative what?
3 over 5.
No. If I have 3/5 and I take away 1, that's 3/5 taken away 5/5. And if I have 3 and take away 5, I don't have a minus 3. I got a negative 2/5, which is the same as this. 3 over 5, x to the 2/5. Would you agree? And now to figure out the slope of the tangent line, I'm going to do that over here, and I'm going to plug 2 into here. So what will that look like? It will look ugly. It'll look like 3 over 5 times 2 to the 2/5. Correct? You can do that on your calculator. Yes?
Would anything be negative on that final equation since you have negative 2 over 5?
When it comes into the denominator, it becomes positive. Okay? So this is the truth about negative numbers. Negative numbers are locations, or what we call directed numbers. Okay? And what they mean is usually direction. So when I see this is really over 1. Okay, when it's in that form. And this negative 2/5 means this needs to be in a different location. It needs to be down here. Okay? So when we say it's a negative 20 degrees, we are saying the location is below 0. Okay? When we have velocity, it means that we are moving the opposite direction than where we initially intended. Okay, or what we call, yeah, does that kind of make sense? So if I would have this in the denominator, Aiden, it would mean it needs to be in a different location. It needs to be above. Okay, that's a very good question. I'm glad you asked it. Because I think there is some confusion with exponents and radicals and fractions. And that's part of this class is, I'm not going to give you 100 problems to do, but in the context of what we're doing, that's a good time to ask, and I'll talk about those, okay? That's how I teach, okay? And it's better for me to answer a question when you have a question than anticipate your question, okay? Are we okay with that? And so you could leave the answer like this, or you could go to your calculator and figure it out. And if you're having difficulty with that, I can show you how to do that. I would actually raise 2 to the 2/5 power, or 2 to the 0.4 power would be easier. Come up with that answer, multiply it by 5, and then do 3 divided answer. Do you guys know how to do that on your calculator? That's the best thing in the world. That's the part I like about my calculator. And it gives it to me, and then make sure my answer is correct to 3 decimal points. That's, because, that's okay to do. Are you okay with that, Denise? Now it asks me to do the second one. Now follow along. I am going to put in a negative 1, right? This means the 5th root of a negative 1. Does anybody know what the 5th root of a negative 1? It asks you, What number can you multiply itself by 5 times and get a negative 1? That's the question. There is only one number you can do that with, and that's what? A negative 1. And then you're going to square a negative 1. And that's going to be positive, right? So my answer here, and then I'm going to take 5 times a positive answer. So for this one, I'm going to have a slope of 3/5. Remember, our whole purpose on this is how do we find slope, correct? That's why we're having these rules. How do we find slopes on these curves? We can come up with derivative formulas that we can plug x values into them. And so this one on this answer simply is going to be 3/5 times 4 to the 2/5 power. Again, you could figure that on your calculator. I would leave it like that. Caitlin, am I doing okay? Does it make sense? All right. So Caitlin, yours is find the equation of a tangent line to the graph f of x equals x cubed, where x equals a negative 2. So equation of the tangent line. Okay? So I need an equation of a line, right? It's a specific line, a tangent line. Okay, so here's my question, and I'm going to ask you this. What 2 things do I need to have an equation of a line? That is the 7th time I've said that this year. Okay? Point and slope. Okay? So I'm going to ask you, do I have either one of those? Not at this moment. Very good. You could be a lawyer. That was a very good response. Okay? So, which one do you want to figure out? Point or slope?
Let's
Find the point first. Okay? How are you going to find the point?
plug in the x of negative 2 into f of x.
Listen to what she said. F of x tells you y, and then you'll have your point. See, with all this work, we have a tendency to forget, how do I get y? How do I get my slope? And I used to think it was you guys. It was me not emphasizing that enough. And so I've tried to be more direct this year. What does f do? What does f prime do? So you're right, you said it perfectly. So I'm going to put a negative 2 in here. And you're going to cube a negative 2 for me, which means you're going to, in your head, do a negative 2 times a negative 2 times a negative 2, like really fast. And you're going to give me what?
Negative 8.
So my point is negative 2 comma negative 8. Okay? You know, this is me being a teacher. This is Caitlin showing her work. Okay? Now, we got the point done. So now you're required to give me slope, correct? So what's the first thing you're going to do for figuring out slope?
You put f of x equation into the power equation.
You're going to take the derivative. And it's already in nice power form. It's like, thank you, Mr. Kruger, for making it so nice for me. You actually gave Denise a harder problem. Okay? And what would you get here?
3x squared.
3x squared. Okay? You're doing awesome. And what am I going to do next to show my work?
You're going to make it into an equation.
Not yet. I want to know a number. Okay? This is the other thing I screwed up on Ty, is people would write this down. This is what people would do. Okay? And I couldn't figure out why they were doing it. I would say a third of the class is doing this. They go, oh, I'm done. And they'd write this, 3x squared times x plus 2 minus 8. Well, here's my point, right? And here's my slope. No, I want a number here. And I go, and I would cry. I would look just like Justin. Justin's going, that's crazy. Because that's not a line, that's a cubic. It's not a line. Because that's a variable. This is wrong. Sad face. You gave me a formula. How do I figure out what my number is?
Once you plug in negative,
Is negative 8x.
once you plug in negative 2.
Yeah, I plug in negative 2 into here. You have to say, okay, what's my x? My x is equal to a negative 2. Okay, so again, now in your head, you're going to take a negative 2, square it, and multiply it by 3. And hopefully not get 7, because that's the next mistake people do. So you get 12. I got my point, I got my slope. So what is this going to be? It's going to be 12 times x minus a negative 2, which is x plus 2, minus 8. Now, Caitlin, this is what I've learned. I check. If I put a negative 2 into my tangent line, do I get a negative 8? Well, negative 2 plus 2 is 0. 0 times 12 is 0. Minus 8 is a negative 8. I always check quickly. And basically what I see is, okay, does that give me 0? And then do I get a negative 8? Everybody, that's just a good thing to do. Doesn't take a lot of time. Are we okay with that? Alrighty. Back to Julia. Julia, y prime is another way to find the correct, or the correct, right? So how are you going to do it in this case? Y equals what? I'm going to rewrite y so it says what? Y equals 5x to the negative what? Do I have a radical? Do I have a 2 here? What? Negative 1. So that means y prime is equal to what, Julia? Negative 2. If you stop there, you got full credit. I want you to get here eventually. Okay? Landry. F of t, you're going to rewrite as what?
2 t raised to the negative 1/2.
Okay. Julia, do you see where you get why he saw a negative 1/2 here?
I just forgot.
What?
I just forgot.
No, that's fine. That's fine. I understand you're going to forget. I totally understand that. That makes perfect. There's a lot to remember. I think that's reasonable. You are never, ever required to be perfect in this class. I mean, I show imperfection more than anybody. Okay? My job is to fix it and not ignore it. All right? So, Landry, back to you.
Do you want me to do the...
I want you to give me the derivative. Oh, and I wrote x instead of t. Sorry. See how easy it was for me to make that mistake? So take the derivative.
Got negative 1 divided by t raised to 3/2.
Positive or negative, did you say? I didn't hear you.
Well, if you're writing it like that, it's negative 3/2.
Negative 3 over 2. And you can write the negative 1. I'm just too lazy to do it. It requires me to actually draw a line. Right? Okay. Jack, do you understand what I'm talking about? I tried to save as much effort as possible. Okay. So then this is how you might see it later on. Landry, you're okay with that?
Yeah.
But if you got to here or wrote a negative 1 this, you'd get full credit. Okay? Ty, dy dx is another way to say derivative. Slope of a tangent line, instantaneous rate. Okay? You're going to see all of those. Okay? Do you think you could figure out what this one is? Or you need a little help?
I tried and I had an answer.
Okay, what's your answer?
I got 35x to the 4 over 16.
That's exactly correct. Okay? Okay? Sometimes what I have happen, Ty, is I have people that take 5 times 7, get 35, and then take 5 times 16 and get 80, and it's wrong. Okay? So this really, you'll see me do this because I hate to tell you, I was that person that did that. And so I write it as that's my coefficient. And I know 5 is 5 over 1, and I'm taking 5 over 1 times 7 over 16 and get 30. Then I'll write as 35 over 16. If you do it this way, it's perfect. Okay? You'll just see me do it a little bit different. Okay? Just because that's how Kruger does it does not mean that's the way that you do it. Kruger is doing it for Kruger, so Kruger gets it right. Okay? That's how you got to remember everything. Okay? Everybody all right on that?
How do you get like 35x to the 4?
How do I get 35?
Yeah, 35x to the 4. Like, how do you get
Okay, so if you look at this as this is my coefficient. See, Julia, he's also asking a question that's, okay, how did that happen? Okay? So if I look at it as this way, in my head, I'm thinking this. Now, I don't want to speak for Ty. I'm thinking of this. I know that this exponent has to multiply this coefficient. Okay? This exponent, this coefficient, since this is a fraction, I have to, in my head, this is how I think of it. I got to take that whole number and write it as a fraction. And when I multiply, I just multiply straight across. So 7 times 5 is 35, and 16 times 1 is 16. Now, that's me slowing down in super slow motion to do that, right? And it's done a lot quicker. Did that answer your question or not? Okay. Yeah.
So if for that set problem, if you have 7 x to the 5 over 3 or over 2, then would you do 7 over 16 times 5 over 2?
So let's say I have a different problem. Let's make sure I got it. So let's say I get y equals 7x to the 5 halves over 16, like that.
Yeah.
Right, so in my head, I would say I got 5 halves times 7 sixteenths. And I would say then my derivative, and I'm going to write it like this because it's less work. Okay, you'll see me do that a lot. It's not to the first power, folks. That's the problem with doing that. I would get 35 over 32 x to 3 halves. Does that help? And that's how you'd see me write it. Actually, you would see me do this first. I always do it that way. Because this is what happened. You got to remember, I was a student. Okay, a long time ago. And I made mistakes. So I had to create a system for myself not to make those mistakes. And I found out if I wrote it like this, I would take 5 halves times 7 sixteenths, and then I wrote it like this with that. And it would be acceptable. Okay? But you have to realize then you can also have this. Yeah, I'll get it that way. Like that. They mean the same thing. And I don't think along the line as you learned your algebra that you had, hey, these mean the same thing type of stuff, or maybe they did and you forgot. You know, there's so much stuff we're throwing at you all the time. Okay, but that's what you see. That's a really good question too. Do you see why it takes so long sometimes in here? Because you guys ask good questions. We doing okay? Okay, which you have this problem now, right, Jack? So do you think you have an answer, or do you want me to show you how I would rewrite it?
I want you to show
Okay, so this is what I would do. I would write that as 1/3. Are you okay with that? And then I take the x separately and I write it to the -4. So in my head, I'm looking at 1/3 times a -4. You understand what I mean? I kind of create them as two separate. I've got a separate coefficient and a separate x to a power. Does that make sense? Okay, and then what do you get?
So it would be -4/3 to the x to the -5.
Right. And I never write that as a mixed number, ever. You know, we spend all this time when you're younger making you write mixed numbers as improper fractions and improper fractions as mixed numbers. I mean, you do a bazillion of them. And then you come here. I never want you to write it as a mixed number. I always want it as an improper fraction because it's not helpful as a mixed number. Like 1.5 is not helpful. 3/2 is a lot more helpful because especially with slope, it tells you how far up or down you're going and how far across you are. Whereas 1.5, what does that mean? I don't know, 1.5 over 1? Now you got to move 1.5 for every 1 unit? I think it's more difficult. At least that's my opinion. The thing you might see, Jack, is this. I'll make it smaller. Are you okay with that, Jack? Did he say yes? Okay. I wasn't paying attention. All right, and then you have sums of differences. And so what they're saying here, I'm done at 20 after, correct? Okay, this is going to work out perfect. What they're saying here is there's actually 3 different functions here. There's a quartic, something to the 4th power. There's a linear, something to the 1st power, and there's a constant. So to take the derivative of this, I take the derivative individually. So what I do, Ryan, is I hide this one. Can you take the derivative of x to the 4th? What is it, Ryan?
4x to the 3rd.
Okay. Minus, can you take the derivative of 3x?
3x to the
N-
-3rd.
Remember, it has an exponent of 1. It's just 3. Does everybody see that? It's going to be 1 times 3, which is 3, and then it's going to be x to the 0 power, which is 1. Okay? It's linear. Only the coefficient times x, which is the slope of a linear line, is what you're going to get. All right? What's the derivative of the 7? 0. The big mistake is people leave the 7. It's gone. It's dead. Everybody okay with that? Derivative of this is 4x cubed. Derivative of this is just a minus 3x. Derivative of that is 0. You can write the 0 if you want. I don't. Blank is 0. Elijah, G prime. Do you want me to rewrite this, or do you think you know this? Okay, what is it?
-6/3.
Yeah, simplify a -6/3.
-2.
Right. I want you to make sure you guys make it a -2 rather than leave it as a -6/3. X to what power? 5th. Okay, what's the next term?
8x to the 1st.
Okay, and I'm just going to write that as 8x. Are you okay? What about this? Plus x. 1 plus 1. What about the minus 11? 0. Are we okay? Notice on polynomials, it decreases by a degree of 1, doesn't it? Will that always happen? Yes. That's an important idea to know. Doing okay? All right, what's on the next page? Oh, nothing! We are going to have lunch. So See you guys tomorrow. This is the only thing we have to do, and then you will have work time, and the quiz will be Friday. Everybody okie dokie.